Hi all, here is the next section, which is going to be talking about graphing absolute value functions. And so, or probably equations, functions. So for learning target, again, just being able to graph absolute value equations and nothing too more super fancy than that. And we'll get to some of the examples in just a moment. And there's only 3. Some of you guys already know some things from absolute value because this is pretty much like an Algebra 1 concept. But we're going to go back and take a look at some of these things so we all are kind of at the same point. And so I'm going to use our lovely little tool of Desmos again to kind of help me out. And so most of the time, and I'm going to change this a little bit, so give me a sec because it's a little touchy. This is going to be an absolute value. An absolute value is what we're going to eventually call a parent function. And so this is like all basic, lovely graph that what it's going to look like. And so I can actually clear out my axes. This is from stuff that I used before in the last podcast. We don't need those labels and so forth. So notice that a couple of things. Number 1, the vertex is at the origin and it's making that V shape. If my absolute value has a number that's being changed by it, which I just called it A, and I represented Desmos to give me a slider, I wanted you to kind of be able to see what is going to occur. So notice as the number gets positive, it's shifting my value up. And as I'm going down, as get negative, it's shifting it down. But notice, other than that, the V stays intact. Okay, it's just going to shift it up and down. So that's what happens when we have an A value. Okay, so I'm going to set that back to 0, if it'll let me. Now, what if I put a number in the parentheses? So let's put in a new slider. So I'm going to put in B here. Now, notice B here, right now, I'm going to change it again to 0. So notice again, here's my parent function. B is not doing anything, still vertex at 0, 0. So now look what happens when B becomes a positive number. I'm plugging a positive number in for B. It's kind of weird because there's a minus there. You'd think that it's actually going to be like moving it the other way, but it's not. So as I put in a positive number into this equation, it's shifting it to the right. And the same thing that happens here. If I'm putting in a negative number, that's going to make that minus sign become a plus, and that's going to actually make it go the opposite direction. So the A value can be trusted. It's going to be strictly what you see is what you get. If it's positive, you're going up. If it's negative, you're going down. Now this, on the other hand, is kind of also that idea, but because of that minus, it can mess you up. So just to remember, if you see a minus and a number, it really means it's shifting the equation to the right, where again, if I see a plus and a number, then that means it's really shifting it to the left. Okay, and so that's kind of what's going on with that function. You also could put in a number in front of the C, I mean, if you really wanted to. And so you can also see like what a whole bunch of things will do with that. But I don't know if that's something I really want to get into at this time. Oh, poopy, I got rid of my A. So you can do a couple of different things. You can, I'll get rid of that C. So I can move these things around. So not only it's just taking the same parent function, but it's just shifting it. So in geometry, we call that a transformation, because that's all it's really doing. It's not doing a reflection or anything fancy like that. And so we can have multiple things acting upon that. So now let's get into graphing. So here we have our first example. So we have f of x is equal to the absolute value of negative 3x. So everything's inside the absolute value. So you're going to do the absolute value last. So because it's going to be nothing's adding to it, there's no minusing or anything on the inside other than multiplying by negative 3, then just keep regular points, like just simple, do like negative 2, negative 1, 0, 1, 2, and then plug those in. So we're going to have the absolute value of negative 3 times negative 2, which will make positive 6, and then the absolute value of 6 is 6. Remember, absolute value is distance from a number to 0. Then if we put in 1, -1, we'll have -3 times -1, which will make +3. The absolute value would be 3. If I plug in 0, we're going to have -3 times 0, which of course is 0. Absolute value is 0. And again, we'll do the same thing. -3 times 1, which will make -3, but we're going to have it changed to +3 because the absolute value of -3 is 3. And the same thing, if you notice the pattern that's emerging here, this will make -6, but then the absolute value, which would be 6. So hopefully you see some symmetry in your particular problems. So 1, 2, 3, 4, 5, 6, just enough room. And again, use symmetry to help you graph the other side. And there's your absolute value. And that's my first particular graph. The next one, and it looks like this. Notice it's got a +1 in there. So that's going to do a couple of things. It's going to be playing with my vertex a little bit. So that's going to get a little wonky. And then the 2 is going to kind of do some things on its own too that maybe you can kind of see what it's going to do. So it is going to shift it, since it's a +1, this is really going to shift it a little bit over. And so that you'll hopefully kind of see that. But it's not too much where we can need to pick different values. So let's just pick the regular values that we picked on the last screen. And so let's computate that. So we're going to have 2 times -2 plus 1, then do the absolute value. So 2 times -2 is -4. -4 plus 1 is -3. The absolute value of -3 is 3. Next, 2 times -1 plus 1. So 2 times -1 is -2. -2 plus 1 is going to be -1. The absolute value is 1. When I do 0, 2 times 0, which is 0, plus 1, and then absolute value of that, which is 1. That's kind of weird. Didn't have that happen before. 2 times 1 plus 1. So that will make 3. Oh, that makes sense. Okay. And then I bet you if we do 2, then we're going to end up getting 5. And I bet you if I did -3, I bet you I would have got a +5 there. So we're going to have 2, 5, 1, 2, 3, 4, 5, and then 1, 3, and then 0, 1, -1, 1, and -2, 3. Now this is kind of weird. It's like, hey, this is my crazy like absolute value, but I have no vertex. And so to help you with that, what you can always do is what we're looking for is basically what's going to make this become 0, because that's going to help me find, the vertex. So we solve this equation, we set it equal to 0, subtract 1, divide by 2, and so I know at -1/2, 0, and that kind of makes sense because it's halfway between these 2 points, that's going to be where my vertex is. And then there's my graph. So that one's not too bad. Notice it shifted my vertex just a little bit to the left. And so that's kind of changing that a little bit. And it's also kind of making the 2 is interacting on our absolute value a little bit as well. Okay, next to the last one. The last one's probably the most difficult because it has the most things operating to it. So we're getting this -1, which is going to do a little bit of shifting. And also we've got that -5. That value we can trust. That pretty much tells me we're going to be moving this graph down. But again, don't need to change the values too much because, again, this is shifting it to the right just a tad. So I don't think we're going to need to deviate from the numbers that we're going to use. The only thing is our graph's going to look a little wonky. And so we're going to just, again, plug the numbers in. So we're going to have absolute value 3 times -2 minus 1. We're going to do that, do the absolute value, then subtract 5. So remember order of operations. So we have to do all the stuff that's in the absolute value bars, then do the absolute value, then finish up the problem. So this will get -6. -6 minus 1 is -7. Absolute value is 7. 7 minus 5 is 2. And so there's my first ordered pair. Okay, if I put in -1, I'm going to have 3 times -1 minus 1, then absolute value, then subtract 5. So 3 times -1 is -3. -3 minus 1 is -4. Absolute value will give me 4. 4 minus 5 is going to give me -1. Then when I put in 0, we're going to end up getting 0 minus 1, which will give me -1. Absolute value will be 1. 1 minus 5 is -4. Ooh, that's kind of a big jump. So notice how, again, this is shifting my V a little bit over to the right. Okay, then let's take a look at 1. So we're going to have 3 minus 1, which is 2. Absolute value is 2. 2 minus 5 is -3. Boy, this is looking like a weird graph. And then 2, 3 times 2 minus 1. So here we're going to end up with 6. 6 minus 1 is 5. 5 minus 5 is 0. And you're like, did I do something wrong? Because this graph looks really, really, really bizarre. And the hard part is we're missing the vertex. And so what we don't have is we don't have a lot of symmetry because we have a 5 messing around with it. We got the 1 and even the 3 that's kind of messing around with how fast this is going to shoot up. So again, I kind of know because of the -5, I know that it's shifting it down 5 units. So the vertex is going to be somewhere around here because that's where -5 is. So somewhere along this line area. And then I'm going to take the 3x minus 1 and set it equal to 0, like I did on the last problem. So I'm going to add 1, then divide by 3. So now I know where it's going to be at. My vertex is going to be at 1/3, comma, -5. So that's here. And so then I just do my best to make that V happen. So my dots are not symmetrical. And the reason why is just because we're dealing with whole values when what we really need is maybe some fractional values. So to recap, just to remember that if there's a positive, like nothing's written in front of the absolute value, then that tells me it's going to make a shape of a V. If I see a negative, by the way, in front of my absolute value, then what I'm going to have happen is it's going to make a mountain. So maybe you can remember the days where you had your little magic math mountains. Then inside here, if it's x plus a number, it's kind of goofy. This one's going to shift it left or right, but it's the opposite of what you think it is. Okay, so remember that if I see x plus 1, so if I see a plus in here, that's really going to shift my graph to the left. And if I have a minus, that's really going to shift my graph to the right. The reason why is the original formula is negative. So it's going to do the opposite of what you think it is. Now, this last part, that is what you see is what you get. So if you see a +3, a plus is going to move it up, and a minus will move it down. And we'll utilize that thought once we jump into graphing parabolas in vertex format. And so that concludes this Absolute Value podcast. And as always, have a great day.